Okay, so now let's look at acceleration rather than changes in position. So here we have a drawing that's supposed to represent a car, which originally starts traveling east at some speed, and then it rounds a corner and ends up traveling north. But it keeps the same speed throughout. And so the question is, in what direction is the average acceleration? So now let's examine what we actually get when we look at these vectors. So we know that the change in velocity is equal to v final minus v initial. And here we're talking about vectors the whole time. And we know that the average acceleration is equal to the change in velocity over the time interval in which this happens. And so we know that this must be parallel to the change in velocity. So if we can draw the change in velocity on this picture, we can figure out what direction the acceleration should be. And so what we're really interested in trying to do is to draw v final minus v initial. And so in this picture, you can see that v initial is pointing this way. So minus v initial will be a vector that's pointing in the opposite direction. So if I go over here to where v final is, and I add to this a vector that points in this direction, this could represent minus v initial. And so if I then draw the vector that connects the base of v final to v initial, that will be the change in v. And so the change in v is going to look something like this. So delta v is going to point from the beginning of v final to the end of minus v initial. And so what that tells me is that the average acceleration is more or less pointing towards the center of this circle. And so if we had to pick a choice over here, we would pick choice 3 as the correct direction for the average acceleration.